Example number 5, we know that if the derivative of sine of x with respect to x is cosine of x. We know that the derivative of cosine of x with respect to x is negative sine of x. We know, after yesterday, that the derivative of tangent of x is equal to secant squared of x. Well, there's 6 basic trig functions, so I'm not going to prove every one of these, but it's based on these 3. So then there would be the derivative of the reciprocal of sine, which is secant. Is it secant? No, wait, it's cosecant, right? Well, I'm writing them out of order. Don't worry about the reciprocal, just write these down. So if I were to go through and take the derivative of secant, knowing it just based on these 2, because secant is 1 over cosine. And so if I were to go through and do the formal derivative of 1 over cosine, I would end up with secant of x tangent of x. Okay, and then if I were to crank through and find the derivative of cosecant of x, I would end up with negative cosecant of x, cotangent of x. And then if I take the derivative of cotangent of x, I end up with negative cosecant of x squared. Okay? And so these are things that we're going to have to know. In fact, I think what I'm going to do is we're going to take, I've got a flashcard, a Quizlet thing. I think we're just going to study those Quizlet cards. It's like 75 terms. That might be what we do next week. And these are on there. We need to know the derivatives of the 6 basic functions, and I apologize, I should have written these in order, but that's okay. You guys know that this is the reciprocal of sine, and that this is the reciprocal of cosine. I was writing it out of the book, and I accidentally skipped one. So now in order to do example number 5, we need to know this, and if you haven't memorized them yet, we're going to do these the rest of the year. The sooner you memorize them, great, awesome. If you want to make a flashcard, because that's how you learn, I would definitely make a flashcard of all the derivatives and all the integrals and memorize them. Okay? So, for example number 5, what they want us to do, or actually, no, I apologize. No, yeah, it's number 5. They want us to find the derivative of secant. Okay? So, what they really want is, they said, all right, y is equal to secant of x, and they want us to find y double prime. And this is where it gets a little tricky, just on there. If I'm given that y equals secant of x, and I need to find y double prime, well then, first thing I need to do is figure out what y prime is, which is going to be secant of x tangent of x. We know that because I just told you that, right? So now to find y double prime, I've got to take the derivative of this. And so what I need to be thinking is, I need to think y equals u times v. And I need to take the derivative of this. So if I want to take the derivative of u v, I'm going to need to use the product rule. Now, does anybody remember what the product rule is off the top of their head?
VU prime plus.
Yeah, it's a plus. Now, this one we could get lucky, but if I say V U prime, and then we do the plus sign, and then we say, and then it's the opposite of that, right? So it would be U V prime. And your textbook writes it differently. Now that one you can get lucky if you do the regular times the prime plus the flip-flop of that, you always get it right. But the quotient rule you cannot guess around. That one you have to get right. Okay? So now what I'm going to do then is I'm going to let u equals secant of x, right? And so u prime then would be secant of x tangent of x. Well, that's a lot, isn't it? Then v would be tangent of x, and v prime would be secant squared of x. So y double prime would be equal to v, which is tangent of x, times u prime, which is secant of x tangent of x, plus u, which is secant of x, times v prime, which is secant squared of x. So what I have is I have tangent squared of x times secant of x plus secant cubed of x. That's y double prime. Now, you might say to yourself, maybe I can clean that up a little bit. Not really. You can, but we don't need to. Because you could look at that and say, well, tangent of x is sine over cosine, and secant is 1 over cosine. And so that doesn't really change anything. So that's it. Does anybody have any questions on that one? No? Okay.